Hi, and welcome to the Unreal Engine News and Community Spotlight. First off this week, we have Frogwares making a really amazing game called The Sinking City, and they did a wonderful thing of walking through and chronicling how they were able to create this really huge map and city generator. So there's a lot of procedural aspects about it. They've made very modular buildings and kit bash those together, but it's all done with a click of the button. And then they just get this huge, massive city that has unique and a variety of buildings. And they've saved themselves hundreds of hours creating a giant map by laying it all out ahead of time. So go read about it. It's really, really cool, and you should definitely check it out. Second off, we have our folks at Autodesk University, and they've mentioned how we've got our ongoing development of DataSmith, and they're enabling the use of Python in Unreal Engine. So it's just a technology sneak peek. You can go read more about it on the blog. And finally, we've got an announcement for EGX Res. So Gamer Network was so thrilled with our Powered by Unreal Engine area at EGX Res that we're helping sponsor a 2-for-1 deal on an exhibition space for teams that will be attending. So if that's something you're going to be taking your game to or taking your team to, make sure to go apply and get that extra exhibition space. It's really awesome. We love partnering with them for that. So on to our weekly Karma earners. These folks are jumping on Answer Hub and answering all kinds of questions for you all. And we just want to give a huge thank you to everyone, Every Nun, Nacht Mare, Shadow River, Death Ray, Una Unagi, Dune, Cold Steel 48, VR Marco, Nico 278, and Firefly 74. You guys just rock my socks. Onto our community spotlight. So first of all, we have a sci-fi captain's cabin by Adam Kenyon. So it's a project he's been working on. It was mostly done in 3ds Max. So there was no ZBrush apart from the neat duvet that he's got laying in there. And I just really thought he did a wonderful job laying out this space. It looks nice and detailed. And he has a little bit of a breakdown. I like he has a dream cast in the scene. It's a nice little touch, but he loosely based it off of Stonemason's sci-fi bunk, and that was sort of his inspiration for this piece. And it just looks really great. So nice job there, Adam. Our second community spotlight is a project called Atrium. So Licht Theater took a vacation to Portugal and saw this in real life and was so inspired by it that he's like, hey, I want to come home and try and make it. So it's just a neat little scene, and just built in a couple of weeks, and I don't know, gives this nice old feel to it, and I think he did a really wonderful job just sort of capturing the essence of this environment. So great job. And our third and final spotlight is by Olga Verbs. It's Another Quest, Another Kingdom. So it's a demo for Game Lunch in Moscow, and they actually built this. It's built based off of a particle system that allows, like in the grass, you can see them change as the character walks over it and smashes it. And it's just a really unique and different use of the engine. I love watching all the critters overlap and chase after this character. Just a lot of fun, and again, trying something new and different and seeing how you can use the engine in non-traditional ways. It just looks awesome, and I would love to run around and try out this game. So great job to the team there. All right, thank you for watching our news and community spotlight. Hey folks, welcome to the Unreal Engine livestream. Sorry about that rough start a little bit there, but hopefully we can sail on from here and whatnot. But
yes, we're here. We made it.
So, first up, we have Ben Mears, who's the Games Community Manager over at SideFX. So today they're going to be going over a number of tools and cool things. But first, you're shooting us with a really great update.
Yes, definitely. Well, first off, thanks for having us on the stream again. It's always
Yeah.
a pleasure. The big news in Houdini world is that Houdini 16.5 was released last week.
Ooh.
It's a great update. I mean, our point releases are pretty much like full releases in themselves. A lot of cool new tools for game dev, so check that out. Epic Mega Jam. So I'm assuming people that are watching the stream probably participated. We gave out like 400 Houdini indie licenses for that, which was awesome.
That's
So
incredible.
thanks to everybody who requested one. And definitely, if you used Houdini to make your game jam, I'd like to know about it. So shoot me a message and I'll try to play your game and check it out. Speaking of game jams, Global Game Jam is coming up in a few months, and SideFX will be sponsoring that. And you can also get a Houdini Indie eval license for that if you're going to be doing Global Game Jam. Nothing's posted about it yet, but stay tuned because that stuff will be coming out pretty soon. And that's actually going along with Global Game Jam. We'll be doing a Game Jam with Houdini contest. So if you do use Houdini for your Global Game Jam game, you can be entered into a contest. We'll have some cool prizes, some cool sponsors. Unreal Engine will be one of those sponsors. So yeah, stay tuned for that stuff as well. And that's really all I have. So now we can get to the good stuff. We'll have Luiz and Paul giving some talks. We have some SideFX people in the chat. So if you have questions, throw them in there and hopefully they'll get to them. And yeah, I hope you enjoy the stream.
Awesome. Thanks for that intro. And we'll be right back with Luiz. Hey, Luiz. Welcome. We're excited to have you on. So you're going to run through a number of tools. He's their senior technical artist. So if you'd like to dive in, go for it.
All right, thanks everybody, and it's really great to be here. I'm going to be following along with my own slide deck over here, so if I look out to the side, that's what I'm doing. My name is Luiz Kruel, and I'm a senior tech artist over at SideFX. We're really happy to be here talking a little bit about some of the tools that we've been building, some of the updates that has happened in 16.5. I'm going to start talking about some of the things we're building, give a little bit of an overview, and then we're going to hand this over to Paul, who's going to finish us off with some of the tools that he's been working on. So if we go to the next slide. So yeah, like we said, Ben is going to do the update already, which you guys saw, a bunch of Game Jam stuff, which is awesome. I'm going to give a quick overview of Houdini itself for those that are new to it. It should be quick just to kind of get if you're completely new to Houdini, just what the hell is it and what does it look like. Then I'm going to get into some of the game tools that we've been building for 16.5. I'm going to get into some of the tools that Mike Linden, who has joined us and is currently on chat, has built for doing effects, some of the upgrades of the tools that I've built and showed last stream. Then I'm going to go into the OpenStreetMap tools, which is kind of cool, and it's the beginning. It's kind of like a little teaser of some of the tools that's going to be coming closer to GDC, but you can see some of those. Going to knock it out with some pivot painter, destruction, terrain, and scene cleanup. Go to the next one. So this is what Houdini looks like for people that have never used it before. It's essentially a digital content creation software, so it's a DCC app. And it is, the nice thing about it is that it's node-based, it's procedural, so that means that it's non-destructive. So as you move things around and you kind of rejig your node network, everything gets recalculated. And not only can we do models, we can also do textures, animation, effects. And we've been around for actually 30 years, SideFX has, which is the kind of company that develops Houdini. And Houdini has been celebrated the anniversary of 20 years of Houdini last year. So it's been around for a long time. It's a really robust set of tools. It's been mainly used in film, but games is getting a lot for the past few years. So we're going to focus specifically on that. So the next slide, I'm going to show a little bit of what it feels like to work inside of Houdini. So here we have a Houdini interface. You can see I can just hit tab, and then I have all these options for all these different nodes. I just dropped a box, and then I can drop a bevel node. I can have all the kind of parameters that you expect out of a bevel tool. And then I can just kind of keep working, right? I can add a normal because my normals are kind of funky there on the corner, so I want actually area-weighted normals. I want to be able to kind of go back up a level, tweak my bevel a little bit, even though I've already set my normals. The whole process is pretty fluid. I can start just kind of playing around with it. Houdini is really nice at basically this interactive, almost prototyping. And the nice thing is that you're basically essentially building tools. So all of these nodes that you're seeing here can be encapsulated into other nodes. We'll get into that a little bit later. So here I dropped in a new Boolean tool that's new in 16. And the cool thing about this tool, not only is it incredibly robust, I can actually pull out some of the data from the operation. So in this case, I was able to isolate the seams of where the two objects intersect. And then I can feed that group into a bevel node, which is the same node that you saw before, but now I'm actually driving it with essentially an edge selection. I can also just rejig the network at any point in time. I can pull out the normal node that I had further up and pulling it back down my chain. And this, for people that are kind of familiar with the procedural workflow, is fairly normal. But if you're used to a destructive workflow, this feels like wizardry, because at any point in the network, you can kind of just start going in and change the resolution of the objects. You can start rewiring things together, so you can use the same originally two objects, but you can now do a separate Boolean, and you're going to use the Boolean now for getting the box to cut the tube as opposed to the other way around. You can also do some expressions, so you can actually set the pivot of the object to be the bottom of the object. So now as you're moving it around, you can see that it's scaling from where you'd want it to be. And then I can do another bevel and play with those parameters. And here you're saying that I'm beveling actually some of the areas that I don't want to be beveling. So I can turn on ignore flat edges, and that will just kind of give me the bevel that I want. And you can change the bevel type back. And what I want to do is actually merge these two things together. So I'm pretty happy. I can actually go back and change that tube all the way in the beginning. And I want to merge these two objects together because right now they're kind of separate chains. I want to merge them, and then that normal that I dropped in the very beginning, I'm just kind of been carrying it around. So now I kind of dropped it off to the end. And this is the kind of highest level of procedural modeling that you can do in Houdini. You can see, like, I can go back all to the first box that I dropped and modify things around, and the whole chain kind of works together. So it's not your traditional destructive workflow that you're kind of clicking and selecting points. You're kind of working with parameters and setting up these complex networks with fairly quick workflows. So if we go to the next slide, you can see that the core of Houdini and the heart of Houdini really is these nodes. It's all about this encapsulation of complex networks into a higher level node and a little network. We call these nodes basically Houdini digital assets, or HDAs. So in this example, I'm encapsulating something that is fairly complex, like calculating the curvature of an object. There's a lot of math and a lot of different types of calculations that can happen, and I'm just abstracting that up a level. So all the artist has to do is just drop a single node, and it has all these other nodes inside of it, which makes this great for pipelines. So as a tech artist, I can build one of these nodes, encapsulate it, and then push it back out. So on the next slide, you can see that we have also something that is called Houdini Engine. And what Houdini Engine does is it can take those HDA assets and actually run that on a third-party app. So even though the tool developer has to build the tools inside of Houdini, the artists themselves can use Maya, Unreal, different third-party engines. And actually, I'm happy to be able to announce today that we are working on a Max plugin. So that's coming. There's currently a kind of community-driven one, but we're working on an official one. So next. So last time I was here, it was in January, and I showed a lot of different things. Basically, we split up the stream into particle and destruction, asset modeling, and kind of mesh processing, and then tools. So we're kind of doing the same thing again. I'm going to show a little bit of the tools that Mike Linden has done for effects. Then I'm going to go in a little bit into some mesh pipeline, or the mesh pipeline is going to come first. And then Paul is going to do some more of the tools. So next slide. We're going to see that in that short time since we last spoke, we've actually dropped 2 versions of Houdini. So 16 was a major release. There's a lot of cool stuff. There's plenty of video out there showing what we've done. The Boolean node that you saw is one of the highlights for the games artists. And then we also released last week 16.5 that even though it's a point release, there's some really, really good features. So I'm going to show a little bit about those in those next slides. So the 2 kind of FXy features that are kind of the big ones for 16.5 are bubbles, which is air incompressibility, which is basically making your fluid simulation respect vacuums and air. So this makes it feel a lot more realistic. And the other one is this narrowband technology that allows you to calculate only the top layer of fluid. So instead of simulating a whole tank full of billions of particles, you only have to do around collisions of objects and then the top layer, which makes it about 3 times as fast, and it consumes about 1/3 of the memory, which is pretty awesome. So on the next slide, I'm going to show a little bit about the modeling updates. So the 2 main features for 16.5 is the polyreduce, which has been completely upgraded from scratch by the same guy that did the Booleans, Bardia, who's a genius. And in this new feature, it not only restained the model a lot better, but it also retains UVs. So as you can see here, we have a model for megascans that we're just decimating it down to 500 polygons. And you can still use your normal maps and your diffuse maps just as you would, and it retains that perfectly. So this is awesome for LEDs. And then the other one is UV Layout 2.0. So UV Layout is our packing SOP. And in this case, you can see just how tightly we can pack it. We can pack it in concave areas and then also in holes. So basically, if you have a no shape, we can pack things inside of it, which not a lot of different apps can do. And then finally, on the UV Layout, you can also tell it how many iterations you want. So a lot of times, you don't really have a lot of control on how long the UV layout's going to take, and it's just going to take a long time to pack because you have a lot of pieces. In our case, you can say how many rotations you want and actually how many different random attempts you can try. So you can get the best possible results. And on the next slide, I'm going to show a little bit of what this means inside of actual pipeline. So in this case, it's similar to a pipeline that I showed last time, but in this case, I'm showing the whole, how everything's done. So we're dropping in a scan data, and we're going to drop in this new polyreduce. I think this is sped up about 1.5 times, but you can see just how fast it crunches. And the nice thing about the new polyreduce is that it will calculate things once, but once they've been polyreduced, you can update it fairly live, which I'll show in the next video. The next thing I'm going to drop that same normal node that I showed in the very beginning. I'm going to drop a couple of them, one for the low res and then one for the high res. Now we're going to drop in Auto UV node, which is new with the game tools that I'm going to get into. And what this does is basically there's 4 different modes of giving you automatic UVs, and we find them pretty robust. So we're going to be able to visualize those UVs. So you can see here's your UV editor, but we're going to see that it slices it up pretty well. And what this allows us to do is then bake. So we have this simple baker that brings in our baker operations into SOPs, which is our modeling context. And you can see fairly quickly, it did a little bit of editing, so we're not waiting for the bakes, but it automatically applies the normal map and the AO. So you can kind of go from a high-res ZBrush sculpt or scan data down to a game res incredibly fast. So if we go to the next slide, I'm going to show a little bit about the power of Houdini really is about changing your mind and kind of going back and modifying things. So in our case, you can see how fast I can scrub on that polyreduce and see it update. So you can kind of pick generally what you want. But not only that, we recently added an ability of basically doing error tolerance, where you can say, I don't want the deviation to be more than 0.05 from my original model. And because the UVs get automatically generated and the whole thing is non-destructive, all we have to do is basically bake our maps again to see what the mesh will look like with a polyreduced version. In this case, I think we're under 1,000 polys, which is pretty drastic, but you can see that the normal map and everything still holds up pretty well. The face gets a little mungy, so maybe let's go back and actually change that tolerance a little bit higher. So at any point, we can just kind of go back in and we can play with those numbers again. So let's see the tolerance set at 0.01. Let's see what this looks like a little bit different. Yeah, let's try that. What this is going to give us is around half of what we had originally. The original one was 7,500. This one is around 3,500. And we feel it gets pretty close. So even though you might not know exactly what is the poly count that you can get away with, you can use polyreduce to kind of help you get that. So here we have something that is 3,500 polys, down from 1,000,000. And I think at real time, this takes around 6 minutes. So it's an awesome workflow for someone that doesn't really want to deal with automatic or with UVing or with poly reduction. They just want to kind of get in and get their models out. So if we go to the next slide. So a lot of these tools and some of the tools like the Simple Baker and actually the Game Baker itself and the Auto UVs are developed by myself, Mike Linden, who recently joined us from the Coalition, and he actually did a webinar for us last year. And then Paul, who's actually a games intern, but has been doing so well that we're letting you talk to you guys. So what we call this is the game development tool set that started around 3 years ago. And we have a shelf now inside of 16.5 that lets you update it from within Houdini. So before you had to go into GitHub and download the tools and kind of move things around yourself. But now it's just built into Houdini. You can download it, update it. Actually, there was a bug today that Andreas hit. And from the time of him telling me the bug to him being fixed and hitting update and getting the tools, it took 57 minutes. So we can do these kind of iterations really, really fast, which is awesome. So if we get a bug, we can fix it, we can push it out to you guys and get you moving. You also have the ability of going to GitHub and seeing even the bleeding latest if you choose to. So next slide. So these are actively used in productions in both games and VR. So we're pretty happy that this is kind of like a side effort, but it has already gained a lot of traction and people are using it. So these are battle tested. So a lot of people are like, wow, I'll wait a little bit to see if they're good, but they've been using it and people are using them in AAA. We're not tied to Houdini builds, so it's not like you have to wait for the next day. Like I said, I can push things out at any time, which makes us really nimble. We can work based on your feedback. And we have around 40 tools. Here's a list of them. But in this next slide, I'm going to show you, we actually have documentation for all of them. And so if you go to SideFX.com, tutorials, game development tool overview, we have a list of all of the tools with links to videos and tutorial pages on each of them. So we kind of try to organize everything for you. And the next slide. So the nice thing about these tools is that we don't have access to the Houdini source code, so we're just building the tools like you would. And because of that, you have access to all of what we're doing. So you can actually dive into any of the nodes that we've done, like the auto UV, and pick it apart and see maybe you don't like the way we're doing curvature and you want to try something different, or you want to try adding some more custom properties. You have that ability. So this is very much like Unreal, where there's two ways of approaching building tools. You can build it as a node-based tools, where you can just drop nodes and really quickly kind of do complex behavior. Or in the next slide, you're going to see that you can actually do just dive in straight into the code. So we have Python, which is pretty standard, Vex, which is our own kind of multi-threaded language. We have the HDK, which is the Houdini Development Kit, which is kind of like a low-level C++, which use the same libraries as we do to build the tools. And then there's all sorts of little callbacks, and we give very, very low-level access to the geometry. So if you want to change things like vertex colors or skinning data or positions, normals, you can knock yourself out and it's all there. So this is very much like the blueprint C++ split inside of Unreal. It's kind of like how we do it here. So next we're going to go into some of the tools themselves. So we're going to start with effects. So these are the tools that Mike has done, and he's in the chat. So if you guys have any questions, please bug him. So in the next slide, we're going to start with this tool called Pyro Preview. And this tool is designed for getting you closer to seeing a final result faster. So one of the feedback that we've gotten is, yeah, it's cool that you can actually get this data and render it out and get it into game, but I want to iterate faster. What are the settings for Mantra, which is our renderer, to give us that best iteration speed? So instead of us writing a tutorial and telling you how to do it, we figure we just build a tool for you that abstract all of that out. So now all you have to do is you drop this Pyro Preview node, and in Mike's case, he's actually using this render region feature that we have in Houdini, where you can just drag a box in the viewport, and that will kick off a Mantra render, so you can actually see overlaid in the viewport what will the final render look like. So it takes, I think, around 15 seconds to get a result, which is a lot faster than it used to be. And as you move the camera around, it just automatically updates, so you can see what your explosion is going to look like. And if we go back into the render view, we can actually see, we're going to see that in a little bit, what the actual final texture is going to look like. So yeah, here we're going to stop previewing in the viewport, and we can use the same node to view it, what your final render is going to look like. And here we can actually see the time from start to finish at real time. It takes a little bit to kick off, but once it's there, it takes around 15 seconds to get a complete frame out. And here you can do really quick iterations of the shaders and the lighting and all that kind of stuff. So the next slide we're going to show, actually, after having done your explosion and you're kind of happy with the way it looks inside of Houdini, you need to actually get that inside of a game engine. So last time I showed you we had this texture sheet swap, which render out all of the image sequences and then put it into a flipbook format automatically. Mike has gone a step further and then made it, instead of rendering out a beauty texture, you can actually do a pack textures. And what that means, if we go to the next slide, you're going to see we're kind of using the red and the green channel to write in our normal map. And then we're going to use basically a grayscale fire texture, which is the temperature from the fire, that we can then do a color mapping or a ramp inside of the game engine. And then the last one, the alpha, is just the alpha as you would see normally. So we go from using 2 textures down to using 1 flipbook. So on the next slide, we can see also we had these normals that we can actually pull from the volumes inside of Houdini. And that gives you pretty good result because you're getting basically the first rate that hits a normal, you get that result. But the problem with that, sometimes it's a little crunchy. And people have asked this trick that's been around for years where you basically have 6 lights so that you can position them and you can drive a normal map from those. So we figure, hey, why don't we offer you guys both of those and let you blend between them. So on the tool itself, you can choose how much of the light rig do you want versus how much the volumes you want. And the next slide, we're going to show inside of Unreal what the material looks like. So in the texture data, we split out the red and the green. We drive the Z from the red and the green channel, funnel that into the normal map. Then the blue channel is that normalized fire, which we can run it through a color ramp. And we use this instead of the black body because we feel we get a little control over the colors as opposed to just getting the black body. And then we can take a color just for the smoke, to see which part is not emissive. And if we see the next slide, you're going to see what this actually looks like composited. And the nice thing about doing this, instead of kind of having to fudge with the dynamic range inside of Houdini and kind of doing operations there, you just do that inside of Houdini or inside of Unreal, which is a lot nicer. And because we're getting those normals, you can actually get the whole thing lit and behaving as you would expect. And the normals are pretty high quality and fairly easy to generate. So if we go to the next slide, we can see what that final result playing back looks like. So you can see it's pretty good. And Mike has done a great job with this tool, and it's available for you guys to download, and a lot of people have been using that. So if the next one, we're going to start talking about what happens if you want to retime that explosion. So a lot of times you might not want a quick flash of explosion. You might want like a big rolling one. And this is a tricky problem to solve because what people tend to do is either they have to render more frames so you can make up for the time, or you have to do some sort of blending. And frame blending will give you a little bit of a cross dissolve, but what you really want is you want to kind of deform the texture towards the next frame, which is called a motion vector, which is very close to a flow map. So if you see on the next frame, we can see what it looks like with the motion vectors. So what we're doing here, it's the same texture sheet that we had before, but now we're applying this distortion field essentially to the texture that warps it perfectly to where the next frame is going to be. And because we are in Houdini and we have access to all the velocity data, we can make those maps fairly straightforwardly by basically taking those velocities and putting it into camera space. The other way of doing this is using kind of like an optical flow technique, which is fairly tricky because you're tracking pixels. So if you have like an area that just has a lot of white and it's pretty blown out, there's nothing to track there. So you're going to have a little bit of a swim effect. So if we go to the next, you'll see this is what the flow map texture looks like. It's a motion vector, so it looks exactly like a flow map. And now you can basically just tweak the time multiplier, and you can see as you slow it down, you can start pushing it pretty slow without having a lot of the issues. And Mike has done a great job solving all of the traditional problems with the crawling on the bleeding edge and figuring out how to interpolate those two frames properly. And there's no magic number, so usually in flow maps there's a couple of magic numbers that you have to tweak, and because we're getting those values straight from the simulation, we don't have to deal with any of that. So the next tool that Mike has built, I think one of the first ones that he did, we saw the tutorial that Ryan Brooks gave here on the Twitch stream, which was incredible, and it showed how to basically get volumes into Unreal using this ray march technique. So we wrote something to write out the data that system takes. So now you can take a Houdini asset and essentially write out this volume slice texture, which is like a CAD scan that can plug into Ryan shaders. So this is awesome, and it looks great, but it's fairly expensive. So we wanted to kind of see how else we can do it. And a lot of people are using this, and they're using this on a kind of cinematic or pre-rendered approach. But we wanted to see what can we do to make it a little bit faster to get good-looking volumes into a game engine. So if you go to the next slide, the solution that we ended up doing is using imposters. So imposters are fairly common now, and the idea here is you have a billboard, and you render out essentially a turntable into a flipbook, and then you use a shader to look up the camera position or the angle towards the card, and lets you look up into a different index of that flipbook. So now we can use actually Mantra rendering, which is awesome film quality renderer, and get that into a game engine when it's just a simple card. So if you see the next slide, you see what this texture actually looks like. So here's essentially just a flipbook, and imposters are fairly common, especially for trees. But we figured we can leverage that technology to kind of enhance it a little bit. So Unreal has a really good tool built into doing that kind of work. But we figured if you can actually do that inside of Houdini, you can get way higher quality rendering. And then the other way we can complement Unreal's tools and system is actually rendering out animation. So the second texture you see, not only are we rendering out a turntable, all the angles around a character, but also rendering out different frames. So if you see the next slide, this is a technique that Andreas Glad showed us on Battlefield, which is to do kind of background characters really, really quickly and really efficiently. So these guys are just running on a particle system, and they're basically cards. But as you move around, they still look like they have dimensionality and they have volume, but they're just flat planes. And if you're doing things far away that you just need kind of like a crowd running in the background, this is a perfect technique. And the tool makes it incredibly easy to use that. So that's it for Mike's tools. If you have any questions about these, please ping him on the chat or ping me. We're going to be here for a little bit. If we go to the next slide, you're going to see some of the tools that I started doing. So OpenStreetMap is this essentially a Google Maps-like interface to be able to download maps, and they're all open source. They're basically community-driven, so people like you and me can go in and generate these, and other people can download it. It's like a Wikipedia, but for the whole world. So what I wanted to do is actually bring that into Houdini. So if we go to the next slide, I've wrote a parser that lets you bring in that OSM data into Houdini. So that gives me all of the street data, but not only that, that gives me all subways and residential versus park areas. It also gives me the buildings. And it's really cool that I can get the buildings, because not only do I get just the building footprints, I get the building heights and also sometimes the building parts. So here I've loaded all of Manhattan into Houdini, and it performs great because it's fairly low poly geometry, but you can see how you can generate a city fairly quickly. So the next tool that I did is generating the buildings from those data. So for cities like Manhattan that have been, or New York, have been done really, really well, you actually get buildings parts. So in the Empire State Building, you can actually get something that looks pretty representative of it, which is pretty exciting and pretty incredible. So this is the beginning of something that we're going to say a lot more of us generating cities, but this is kind of the foundational for that. And just with this, you can do a lot of cool blockout stuff with it. So what I wanted to do is actually bring that into Unreal. So if we go to the next slide, you're going to see, because these are just nodes inside of Houdini, I can encapsulate them and actually make something inside of Unreal that just takes one of those OSM files. So I don't even have to go into Houdini anymore. I can just load something in. So in this case, I'm loading in, I think, is the financial district, just to be a little bit quick. And I can scale it down a little bit and then just throw a gradient based on position. And you have the model fairly quickly inside of Unreal that you can start playing around. Maybe you have a racing game, maybe you have an action game that you want to play around with. And it's pretty easy to get map data block out inside the game engine. Then I also wanted to try a different one. So just for testing, I wanted to bring in Santa Monica so I can see how it's different, but I still get a lot of the building shapes, and you can get pretty close to these guys. They're pretty blocky, but if you start putting textures on them and start to kind of doing the next step, which is what we're going to start doing with decorations and UVs, you're going to see what we're going to get. So the next step is you want to see this being played. So I brought a little bit more, so I think it's all the way up to Central Park, and I threw it into the flying example. So you can see even at a pretty blocky shape, it's pretty awesome to be able to kind of display this, and it feels great. And it's something that if you had to build a city by hand, there's tools out there that kind of give you something, but nothing beats having an actual city that you can either start off with and modify, then you can start picking it apart and take out city blocks, or you can start modifying things, replacing buildings, pulling buildings into your own game. So it's a cool beginning of a new tool set. We're going to show more of this at GDC, but I just wanted to get this started and get you guys appetite whet. So next, I'm actually going to hand this off to Paul. I'm going to be on chat, so if you guys have any questions, let me know. And yeah, thank you so much for having me, and hopefully this gives you a little bit of insight on what things you can do in Houdini.
Awesome.
Thanks, Amanda. Nice talking to you.
You too. Thank you so much for joining us, and we'll be right back with Paul. So welcome back here with Paul. He's a game intern over at SideFX, working on a number of fantastic tools over there, in addition to Luiz and that team. So, thank you so much again.
Yeah, let's go. Let's see what we're doing. Yeah,
we can
cool.
dive in.
All right, so yeah, let's go back to the presentation. So first about me. Hi, I'm Paul Ambrosiussen. I also make game development tools, and I'm also currently finishing off my degree at the NHTV in Breda, the Netherlands. So I'll be talking about a couple of other neat tools we developed, starting with Pivot Painter. So Pivot Painter was originally a 3ds Max exclusive tool provided by Epic Games to allow you to make and create interactive events, which is very cool. So we at SideFX have developed this Houdini digital asset that can do the same for both procedural and non-procedural assets. So if we go to the next slide, we can see what the tool does and what the end result is. The tool basically stores every sub-object, so in this case the branches and the leaves and the hair on the box, and stores the pivot and rotation information of those meshes in the vertex data and UV channels of those. The shader in Unreal Engine can then read back that data to build very cool effects. So all the animated objects you see right now in the background are actually just static meshes not holding any animation, but they're still animated. And this is all done through shader using Pivot Painter. So if you go to the next slide, the question is, how do you set up this tool and how easy it is to use? So let's take a look at this example. In this case, I want to build this abstract effect that requires having access to these sub-object pivots. So in this case, the boxes that I stamp on top of the sphere. So what I do is I take a sphere, copy some boxes to those points, and plug that data into the tool. And almost immediately after, I get my end result. So the Pivot Painter already did its job. I simply import that as an FBX in Unreal, apply the shader I have, and I'm done. I now have a cool animated looking static mesh. If we go to the next slide, we can even take that one step further, where we take a complex object like a tree. The next slide. Yeah, where we take a complex object like a tree. In this case, a tree is pretty complex compared to what we had before. So we have a tree that has branches, and those branches have leaves as well. So if these branches have animation, the leaves attached to those branches also need to inherit the motion the branches have. Plus, these leaves we also want to add some additional motion, right? So as long as you can tell the tool in Houdini which pieces of the mesh are branches and which ones are leaves, Houdini will automatically figure out where the pivot for each of them needs to be. Then all you do is, once again, export it out as an FBX, apply the shader in Engine, and voila, you now have a beautiful tree being animated using just shaders. So this is a very powerful solution rather than animating a tree by using the traditional method like skeleton. So because it's shader, you can have many, many more trees without having a lot of impact on performance. So for the next topic on the next slide is destructions. Everyone wants to make things explode and break, and that is something that Houdini is very good at, right? So you can build very detailed simulations, but those are often way too heavy to directly import into Unreal Engine. So what we need to do is optimize it, right? But often when you optimize these things, you reduce the level of detail you have, right? You get less detail. Not necessarily. So I'm going to show you a way on how to optimize this procedurally and automatically without losing that detail. So we have something that we can plug into the real-time environment, which is what the engine likes. So on the next slide, I built a small demo for this stream where we have this fence breaking. And this ball is breaking through, producing a lot of small pieces, right? In this case, this clip is actually showing two animations, the non-cleaned and the cleaned up version. And they both look the same. So let's take a closer look at how these are set up. So let's compare on the next slide. So in this slide, I've colored all the individual pieces that will get a bone when we were just to export this into Unreal with a unique color. And as you can see, there's quite a lot of these individual pieces with lots of colors. But many of these pieces are actually stuck together and they have similar motion, right? So we need to either manually clean them up and bash them together so it gets one bone rather than, let's say, 5, or we find a procedural solution where it does it for you. So on the next slide, now what I'm going to do is I'm simply going to plug in this simulation into the tool. And what we can see now is that the tool automatically figured out which pieces share similar motion and bash them together with each other. So that's a big difference in terms of performance, but visually, they're both identical. So on the next slide, in this case, we can see we have a wall on the right side, right? And this wall consists out of many, many small pieces. But when we break this wall with a ball or something else, we can see that only a few pieces, get broken loose, right? So if we were to import the left one, we would see that we would get over 2,000 bones, resulting in a memory consumption of 1.9 megabytes. While if we simply run it through this cleanup tool, we're going to have 59 pieces consuming only 60.2 kilobytes. So that's a big difference. And of course, because it is a slider and it's all procedural, what you could even do is play around with the interface, drag around the slider, and even build level of details for your simulation. So you can have a very complex looking one with lots of detail on the foreground, and if you get further away, you could simply swap out that skeletal mesh with a low version one. On the next slide, I import this into Unreal, and what you see now is the skeletal view overview with the animation, and all the white lines you see are actually individual bones per piece. And what I'm showing is a comparison between the non-clean version and the clean version. So there's a difference. The non-clean has 205 pieces, while the cleanup version has only 81. So that's a big difference, right? Let's go to the next slide. And what we see now is I put both of them shaded into the engine next to each other so we can see what the comparison is. They both look identical, right? And the cool thing about this tool is we now allow users to build very cool simulations. Doesn't matter how big they are. You can just run it through this tool and you get something cool into Unreal Engine. So you don't necessarily need a AAA studio manpower team, since the tools we're developing for you are there to help you. So you only need to focus on the creative aspect rather than having to worry about performance and getting it to work into Engine. So for the next tool, on the next slide, we're going to talk about terrains. So Houdini offers very powerful procedural terrain tools that allow you to generate and even simulate beautiful terrains. So what you're seeing right now on the next slide is layering on all sorts of detail to get cool looking procedural terrain. So what you see right now is lots of masks being layered on top of each other, which in the end all get converted into a format that we can use in Unreal Engine. So I can put down some splines to generate roads, and all that information will be stored in a layer. So in this case, if I also generate a layer that resembles foliage, or where I want foliage to be spawned, I can load in that data and procedurally spawn foliage based on that mask. So as soon as, for example, you change the position of a road, everything around that in the terrain will automatically update, and things like houses or foliage will automatically update and be perfect again. But the question is, how do we get this into the engine? Let's take a look at the next slide. The question is, let's get it into Engine, right? So the first tool is a tool that will convert your terrain into mesh chunks, right? Into separate pieces. There's two ways of doing this. The tool allows you to generate two different types of UVs. The first one being every single chunk will have a UV, which in total is being mapped from 0 to 1, as you can see on the left side. But there's a different solution which also allows you to map every single chunk from 0 to 1, giving you more resolution and allowing you to port your pipeline into a similar system such as World Machine, right? So on the next slide, we can see that the tool also gives you control over the meshing that happens with this terrain. You can either generate a nice uniform quad mesh, or you can get an adaptive quad mesh that will put polygons where you need them. So if you have a very flat terrain, the tool won't put polygons there if you don't want it to, and it will put polygons in the areas where you need them instead. So this is great for example, backdrops, or if you simply use the Houdini terrain system to build cool-looking rock formations that you're going to use as assets in the levels. on the next slide, we can see that I also imported these meshes into Unreal. So you can just walk around on them, you have collision, and that all works nicely for you. There's a different way of doing it, which we can see on the next slide, which is rendering all your terrains into texture data. The tool can render out height maps, cavity maps, occlusion maps, and even normal maps. The tool also allows you to split these big maps into smaller tiles, just like the mesh tool. So those two tools work perfectly together. So in this case, if you walk around in the terrain, you can simply load in small sections of the height map with the world composition node, and you gain a lot of performance. But the question is, on the next slide, Houdini is all about proceduralism. So are we able to keep this proceduralism into Unreal, right? Let's see on the next slide. So what often happens is that a level artist or a level designer comes up to you and asks, could we please move that mountain a little bit because I need to spawn a village somewhere, or I need a road to be somewhere. And if you already built your terrain in Houdini, you would need to go back and change how that mountain is placed, import it back into Unreal, the level designer makes a change again, and you will need to keep doing that, resulting in lots of wasted time. So let's take a look at the next slide. There actually is a way of keeping a proceduralism in Unreal. So in this case, I converted my entire terrain into a Houdini digital asset, which I load into Unreal using Houdini Engine. So I can now generate roads using, for example, splines or curves I put down, or I can even generate volcanoes by simply putting down some cones like this example, right? So all I need to do is build the functionality in terms of rule sets in Houdini, and that allows level artists to give that tool to level designers. And now the level designers are able to produce final art without having to go back to a level artist and ask them to update something. So in this next example, there's another cool thing, which is called Scene Cleanup Tool. So let's say you're building a cool rock formation, which you can see on the next slide. Shout out to Chico and Daniel for providing me with these rocks. We can see that lots of these rocks have been, clustered together and stacked on top of each other, meaning that there's lots of hidden triangles, either inside the meshes or hidden underneath the landscape. So what we could do is we could either export this out into Houdini and remove those triangles manually, or once again, we could build a procedural solution in Engine using Houdini Engine. And if we do that, we can keep changing how these rocks are placed in Unreal, even add new ones, and the tool will clean this up behind the scene. So this is a very powerful tool that allows you to iterate very fast and allows level artists to not having to worry about performance too much, because everything gets cleaned behind the scene. So that was it for my tools. So let's go to the next slide. I'd also like to leave you with a couple of cool resources. To start off with, check out our cool webpage at SideFX.com, where you can read all about our new Houdini release, and of course what our customers have been up to recently. We also have a new forum on our website, specifically made for real-time users, so please check it out as well. And we also have lots of cool tutorials on our website made by both us, from SideFX, and also the awesome community. And of course, there's also a Discord server hosted by the community called Think Procedural, where everyone is able to share knowledge and help each other out. So if you're using Houdini for your projects, be sure to let us know, and we'll be happy to promote it. So thank you.
Those are so many awesome tools. I hope you've all been inspired to go take advantage of Houdini. They obviously have a number of fantastic tools and integrations with the engine and things that make
Of course,
your
yeah. And
life
if you have
easier.
questions about how to use certain tools, just send us a message. We'll be happy to answer those for you.
Yeah, and we want to encourage, if you have additional questions, again, he mentioned their Discord, the Think Procedural Discord, or you can toss questions on the event forum post. I'll drop it in a link in the chat for the forums for the event. And so we'll point them that way, make sure to answer all your questions. We don't have a lot of time or really any time for Q&A today since we got off to a late start, but we want to thank you all again for coming out. Thank you, Paul, again, Luiz, and Ben for jumping on. There's a lot of really amazing stuff you guys are working on over there. So no stream next week because it's Thanksgiving and we won't be here, but we'll see you all in a couple of weeks for those Mega Jam results. Bye.
Thank you for